Hey guys, so this is lesson 3 of our virtual learning, and today's is just a practice day of what we learned the last 2 days. So we're going to be using trig ratios and inverse trig ratios for today. So we use trig ratios for sides to find the sides, and inverse trig ratios are to find the angle measure. So let's take a look at this first one here. So we're finding a side, so we know we have to use regular trig ratios, and we use SOHCAHTOA for all of this, so I'm just going to write it at the top of every single question. So we have 39 degrees here, so 11 is opposite, and then x is adjacent to the 39 because it's connected to the 39 degrees. So we're going to use the tangent function. So tangent of 39 is equal to the opposite, which is 11, over the adjacent, which is x. So multiply each side by x. These will cancel, so you get x times the tangent of 39, and that's equal to 11. So since we're solving for x, we then need to divide each side by the tangent of 39. So x is equal to 11 over the tangent of 39. Let's plug that into our calculator. Reminder that your calculator should be in degree mode. Again, mode, make sure it's on degree. All right, so we want 11, and we're going to divide that by the tangent of 39. So I'm going to round that, x equals 13.6 for number 1, okay? Okay, number 2. So let's write SOHCAHTOA at the top again. SOHCAHTOA. All right, so 46 degrees, so it looks like we're finding a side, so we're just going to use regular trig ratios. We have the hypotenuse because it's across from the 90-degree angle, and we have the adjacent side because it's connected to the 46 degrees. So we have the hypotenuse and the adjacent, so we're going to use cosine. So we're going to use the cosine of 46 is equal to the adjacent side, which is x, over the hypotenuse, which is 28. So for number 2, we're going to multiply each side by 28. These cancel. So 28 times the cosine of 46 is going to equal x. So let's plug that into our calculator. So 28 times the cosine of 46. So we're going to get 19.5 is equal to x. So x is equal to 19.5. Okay. All right, the next one. All right, so now we're looking for an angle. So when we're looking for an angle, so I'll just make a note, looking for an angle, you're going to use inverse trig. Okay, so we still are going to use SOHCAHTOA. All right, so we have the hypotenuse because 22 is across from the 90-degree angle, and we have the side adjacent because it's connected to x here. Okay, so we're going to use cosine. So now we have the cosine of x is equal to the adjacent, which is 14, over the hypotenuse, which is 22. Okay, so remember correctly, we had to do the inverse of both sides. These would cancel, so x is equal to the cosine inverse of 14 over 22. So let's plug that in to our calculator. So remember, we did the second key, cosine, so we get the cosine inverse, the -1, 14 over 22. So x is equal to about 50.5 degrees. So x is equal to 50.5 degrees. Okay. All right, number 4, we're looking for x again, so we're going to use inverse trig because we're looking for an angle. That's right. SOHCAHTOA at the top. right? So we have this side, we have the hypotenuse, because this is across from the 90. And we have the side opposite. This is the side opposite, the x. It's across from the angle. So we have the opposite and the hypotenuse. So we're going to use sine. So the sine of x is equal to the opposite, which is 10, over the hypotenuse, which is 19. So x is equal to the sine inverse of 10 over 19. So I plug that in. So second sine, 10 divided by 19. So x is equal to 31.8 degrees. All right, let's look at this last one. So we're looking for a side in number 5, so we're just going to use regular trig functions. We don't need an inverse, so katoa. So we have the hypotenuse, and we have the side opposite, the 24-degree angle. So opposite and the hypotenuse is just sine. So we're going to do the sine of 24 is equal to the opposite, which is x, over the hypotenuse, which is 31. So we're going to multiply 31 to both sides. So 31 times the sine of 24 is equal to x. So 31 times the sine of 24. So 12.6. So 12.6 is equal to x. Okay. All right, now I just want to go through 2 application problems. Similar to how we had Pythagorean theorem applications, we also have trig applications. So a ladder is leaning. So whenever we had this word leaning, we always said that this was the hypotenuse against a wall, and it makes an angle of 75 degrees with the ground. If the foot of the ladder is 6 feet from the base of the wall, what is the length of the ladder? So if we draw our picture, we know that the ladder is leaning, and we want to look for the length of the ladder, so we're looking for x. We know that the angle that it creates is 75 degrees, and the foot of the ladder is 6 feet from the base of the wall. So this must be 6, because if this is the wall and this is the base to the ladder, it's 6. So we're going to use our trig ratios here to set this up. So TOA. So here's our 90-degree angle. We have the hypotenuse and the adjacent side. So we're going to use cosine. So the cosine of 75 is equal to the adjacent, which is 6, over the hypotenuse, which is x, because we're looking for that length of the ladder. And we know because the ladder was leaning, that's our hypotenuse. Let's pi each side by x. So x times the cosine of 75 equals 6. Divide by cosine 75. So x is equal to 6 over the cosine of 75. And when I plug that into my calculator, 6 divided by the cosine of 75, I get 23.2. So x is equal to 23.2. Okay. And this last one, Miss Gresco's sister Grace is flying a kite and lets off 275 feet of string. If the kite is 150 feet above the ground, assuming the string is straight, what angle does the string make with the ground? So we're looking for angle, so that tells us we're going to use inverse, trig. Okay, so if my sister is flying a kite, so when you fly a kite, it's at an angle. So this whole piece is 275. The kite is 150 feet above the ground. So if this is the kite up top, it's 150 feet above the ground. We don't know what this is, but we are looking for this. We're looking for this x degree. We're looking for that piece there. So we are going to use inverse sine, because this is my 90-degree angle. I have my hypotenuse, it's across from the 90, and I have my opposite side. So I have sine. So I'm going to use the sine of x is equal to the opposite, which is 150 over 275. So x is equal to the sine inverse 50 over 275. When I plug that into my calculator, so second sine inverse of 150 over 275. So I get that x is 33.1 degrees.